Hello my friends, and welcome back to the You Can Do TV channel. The production process of a high-end Beretta firearm is a perfect blend of modern technology and traditional craftsmanship. It begins with a careful selection of materials, such as high-grade woods and metals. These materials are chosen for their durability, functionality, and aesthetics, ensuring that the final product is both reliable and visually appealing. Next, the components of the firearm are precisely machined, using advanced technology to ensure the highest standards of accuracy. Computer-controlled machinery shapes and refines each part, while human craftsmanship ensures that every part fits together seamlessly and functions properly under real-world conditions. Each component undergoes strict quality control to detect any imperfections early in the process. The artisans will select parts of the gun stock, usually made of wood or metal, to engrave. They use specialized tools such as knives, chisels, and abrasives to create small, sharp details. Each motif is meticulously engraved by hand, ranging from traditional patterns to more elaborate and personalized images that reflect the customer's taste or the heritage of the firearm. This process requires absolute precision, as even the smallest error can affect the aesthetics and value of the gun. Once completed, the stock is further machined to give it a smooth and polished finish, while also enhancing its durability and comfort in use. Once the components are machined, skilled craftsmen hand-assemble the parts, applying their expertise to ensure everything fits together perfectly. This step requires extreme precision, as even the smallest alignment error can affect the performance, safety, and longevity of the firearm. Beretta's artisanal approach contrasts with the bespoke craftsmanship of Arietta shotguns, which cater to elite markets but raise questions about the accessibility of such luxury firearms. The production of Arietta shotguns begins with selecting high-quality materials, including special steel for barrels and premium walnut for stocks. Barrels are made using the chop slice method, welding steel pieces for maximum precision. Mechanical parts like locks, hammers, and triggers are handcrafted for perfect fit and function. Grinding and chiseling are done by hand. Parts are hand-assembled, especially the side locking system, a signature feature. Engraving is distinctive, with artisans hand-carving floral motifs to hunting scenes, giving each shotgun a unique look. Stocks are shaped and polished, with natural oils for durability and aesthetics. Each shotgun undergoes rigorous testing for accuracy, performance, and functionality, ensuring high quality. The result is a reliable hunting tool and a work of art, combining craftsmanship with precision. While Arietta's bespoke shotguns cater to niche markets, the mass-produced AKM rifles by WBP Rogow serve global demand, sparking debate over the widespread availability of such durable firearms. WBP Rogow, a renowned Polish arms manufacturer, specializes in the assembly of AKM rifles, one of the most iconic variants of the Alaska 47 family. The assembly process at WBP Rogow involves several key stages, ensuring the creation of reliable and robust firearms. The first step begins with the careful selection and preparation of parts, including the receiver, barrel, trunnion, and various internal components. These parts are either sourced from high-quality suppliers or produced in-house to meet stringent standards. The receiver is typically stamped or machined, depending on the model being assembled. Once the parts are ready, assembly begins with the installation of the trunnion and barrel into the receiver. The barrel is secured, and precise alignment is critical to ensure proper functioning and accuracy. Following this, the gas block and front sight assembly are attached to the barrel, followed by the installation of the handguard retainer. The next stage involves assembling the trigger mechanism, which includes the disconnector, sear, hammer, and trigger, all carefully fitted into the receiver. The safety selector is installed and tested for smooth operation. Afterward, the bolt carrier group, consisting of the bolt, firing pin, and carrier, is assembled and fitted into the receiver. The final steps of assembly include installing the stock, pistol grip, and magazine release. The rifle is then checked for proper head spacing and alignment. The completed rifles undergo rigorous functional testing, including firing tests to ensure reliability, accuracy, and safety. After passing these tests, the rifles are cleaned, lubricated, and prepared for shipment. WBP Rogow's commitment to quality ensures that each AKM rifle assembled meets the high standards expected by military and civilian customers alike, providing exceptional durability and performance in challenging environments. The AKM's reliability hinges on components like its magazine, whose rugged production process underscores simplicity, though its global proliferation fuels controversy. The AIM 2023C is a high-speed, fully automated inspection machine designed for cartridge container quality control, capable of processing up to 24,000 units per hour. The system features a multi-stage inspection architecture, beginning with an in-feed tray and screw system that guides containers through a series of star wheels and turrets. Key modules include the pre-spin turret, inspection main and sub-turrets, and advanced SD sensors for particle detection. Comprehensive inspections cover cap integrity, side/top, crimp quality, plunger top, air gaps, and potential cracks, both internal and external. All inspection results are evaluated in real time, with defective cartridges rejected into dedicated trays, ensuring precision, safety, and compliance. Beretta's firearm production emphasizes precision and efficiency through automation. Barrels are produced using hammer forging, shaping metal under high pressure, followed by chrome lining for durability, a complex step. Some pistol barrels use broach cutting for specific applications. CNC machines and robots handle machining, minimizing supervision. Robots self-monitor and replace tools, alerting technicians remotely. Assembly reflects craftsmanship. Each over and under, or side-by-side shotgun undergoes over 2 hours of hand fitting. Even semi-automatic models involve critical hand alignments and tests. Every firearm is inspected and tested for reliability and performance, integrating automation and artisanal techniques. Beretta's blend of technology and craftsmanship is further refined in their high-end firearms, where intricate detailing elevates production to an art form, inviting scrutiny over the luxury of weaponry. Tactical kinetics, rifle barrels are manufactured with precision. Blanks are loaded into a 4-spindle automated gun drill for reaming and rifling. Barrels are reamed to size and polished for a smooth finish. Rifling achieves the desired twist rate, followed by stress relief. Each barrel is checked for concentricity within a thousandth of an inch. Barrels are chambered, headspace measured, and surface finish checked before coating. After rigorous quality inspections, barrels are packaged and shipped. The precision in tactical kinetics barrels is validated through rigorous testing, ensuring reliability that parallels the meticulous assembly of firearm components. At Tactical Kinetics, .308 barrels undergo rigorous testing for performance and reliability. Function testing checks mechanical conditioning and operation, manually loading rounds to ensure smooth cycling without malfunctions. Accuracy testing at 100 yards stabilizes the rifle on a bench rest with a bipod. After conditioning with 10 to 20 shots, 3 round groups are shot. If groups meet the 3/4 inch accuracy standard, the barrel passes. Otherwise, it undergoes refinement. This ensures only high-quality, reliable barrels are delivered. The focus on barrel quality extends to pistol manufacturing, where precision processes ensure performance, tying small arms production to broader defense needs. To manufacture a pistol barrel, a 48-inch bar of 416R stainless steel is loaded into a bar loader and machined on a lathe. The outer diameter is termed, threads added, and a lollipop shape created for 5-axis milling. The chamber, feed ramp, and locking block geometry are added for slide fitting. The barrel is tumbled to protect threads, followed by an ultrasonic wash to remove debris. It is honed to achieve the final bore size. Rifling is cut using broaching, and the barrel is blasted before heat treatment and coating. Precision in pistol barrels complements accessories like night vision sights, which enhance tactical performance but spark debate over their role in civilian and military applications. To install night vision suppressor height sights on a Glock 43X, begin by performing safety checks to ensure the firearm is unloaded. Remove the magazine and check the chamber to ensure it is clear. Next, remove the slide from the gun. If you have a threaded barrel, take off the thread protector and remove the recoil spring. Use a sight pusher tool to remove the factory front sight. Tap the sight out with a file or a punch tool. For this step, remove any reflex mount or plate if applicable. Afterward, place the slide into the sight pusher and push out the factory sight. Now, install the night vision sights by inserting the front sight and tightening it with the provided screw. Repeat this process for the rear sight, using the sight pusher tool to install it and securing it with the set screw. Reassemble the slide by inserting the barrel back into the slide followed by the recoil spring. Replace the thread protector. Finally, reattach the slide to the frame, and your Glock 43X is now ready for testing at the range with suppressor height sights installed. The precision of firearm accessories ties to the production of large caliber munitions at facilities like Scranton, where scale meets stringent quality demands, raising questions about military-industrial priorities. A new circular saw with an integrated robot cuts round bars up to 95% faster, reducing E120mm cutting time from 6 minutes to 20 seconds. This fully automated system, unique in the Netherlands, operates 24/7 and handles bars up to 180mm with outstanding precision. Length tolerances nearly -0/+0. It ensures shorter delivery times, consistent high-quality finishes, and maximized efficiency. Ideal for mass production, it lowers labor costs while boosting output and meeting tight industry tolerances. The Scranton Army Ammunition Plant, SCAAP, operated by General Dynamics Ordnance and Tactical Systems, specializes in large-caliber metal projectiles. SCAAP manufactures 105mm to 155mm artillery shells, including high explosive and extended range variants. Steel forgings undergo machining, heat treatment, and finishing. Advanced CNC equipment ensures precise tolerances, with automated inspection for quality control. Shells are heat treated for durability, followed by surface finishing, painting, and stenciling. Robotic handling enhances safety and efficiency. Supporting U.S. and Allied operations, SCAAP ensures munitions readiness and surge capacity. Modernization, including high-efficiency furnaces and digital systems, positions SCAAP to meet growing demand for artillery ammunition. Scranton's large-scale production is detailed in its mission to produce 155mm shells, a process that underscores the global demand for munitions but prompts scrutiny over their use in conflicts. Inveriti Presse is revolutionizing ammunition production with its in-house designed and developed deep drawing system. Their advanced transfer presses enable high-speed production of essential ammunition components, starting from brass or steel strip. This enables precise deep drawing of shell casings and bullets, delivering unprecedented production efficiency. Capable of processing both small and medium calibers, Inveriti machines ensure optimum precision and significantly reduce production costs. The fully automated process integrates multiple stages, forming, drawing, and final shaping, into a single streamlined operation, significantly improving throughput and consistency. Inveriti Presse's proprietary systems exemplify innovation in the field of defense manufacturing, making it possible to produce high-quality ammunition components with speed, precision, and cost-effectiveness. The process is monitored and controlled by experts. Whether for military or civilian applications, their equipment offers scalable solutions tailored to modern production needs. Inveriti's automated efficiency is mirrored in the Mark 7 autoloader, which streamlines ammunition loading, highlighting the push for speed in defense production. The Mark 7 autoloader is a high-performance ammunition loading system, processing up to 2,100 rounds per hour. Engineered for precision, it automates loading, minimizing human error. Equipped with sensors and robotics, it handles various calibers, offering flexibility. Widely used in commercial and military applications, its speed and accuracy make it ideal for high-volume demands, streamlining operations. The automation in ammunition production ties to broader manufacturing innovations, like the robotic circular saw, which enhances defense supply chains, but raises questions about over-reliance on technology. In 2017, Lockheed Martin met its goal by delivering 66 F-35s, a 40% increase from 2016. Over 260 jets had been delivered globally by year's end. With production scaling to 160 jets per year by 2023, costs continue to fall, aiming for $80 million per F-35A by 2020. While production ramps up, ensuring the F-35's long-term reliability through structural testing is critical. An F-35A airframe completed a rigorous 24,000-hour structural durability test at BAE Systems in Brow, East Yorkshire, simulating 3 full lifetimes of operational service. The 350-ton test rig, fitted with over 20 miles of wiring, 2,500 strain gauges, and 160 hydraulic actuators, replicated real-world flight loads to assess strength and safety. The airframe will be shipped to Lockheed Martin in the U.S. for detailed inspection. This testing identifies potential issues before they occur in the fleet, ensuring long-term reliability and performance. The F-35's durability testing reflects the evolution of manufacturing facilities like Air Force Plant 4, where decades of innovation have transitioned from the F-16 to the F-35, raising questions about the sustainability of such large-scale defense infrastructure. The F-35B and F-35C variants of the Lightning II represent a leap in 5th-generation fighter capabilities tailored to specific military branches. The F-35B, developed for the U.S. Marine Corps, features short takeoff and vertical landing (STOVL) capability, allowing operation from amphibious assault ships and austere runways. Its lift fan and swiveling rear exhaust enable vertical landings, ideal for expeditionary missions. In contrast, the F-35C, designed for the U.S. Navy, is optimized for catapult launches and arrested landings on aircraft carriers. It features larger wings, stronger landing gear, and enhanced range and durability for carrier operations. Both variants integrate stealth, sensor fusion, and advanced communications, ensuring unmatched situational awareness and joint force interoperability. The F-35B and F-35C enhance tactical flexibility and ensure dominance in contested environments, bringing multi-domain lethality to sea-based and forward-deployed operations. The F-35B's role in naval aviation, particularly for the UK's Royal Navy, underscores its transformative potential, though its high costs and specialized capabilities spark controversy over naval budget priorities. The F-35 undergoes rigorous testing to ensure operation in extreme conditions. This chamber replicates the coldest and hottest environments, from Arctic freeze to Death Valley heat. The F-35's ability to hover, take off vertically, and fly with full afterburner was tested here. Advanced exhaust systems and innovative engineering guarantee readiness for any climate during its 40-year lifespan. Climatic testing ensures versatility, but additional trials in rain and humidity further validate the F-35's reliability, prompting discussions on whether such extensive testing is necessary for all global deployments. The F-35 undergoes rigorous rain and humidity testing to ensure operation in extreme weather. This includes simulating high humidity and rain environments. The aircraft is subjected to steady rainfall, up to an inch per hour, for extended periods, and wind-blown rain with crosswinds. A rain frame controls water intensity. The testing ensures reliable function in diverse global environments, preparing it for real-world missions. Weather resilience complements the F-35B's unique vertical takeoff capability, a feature that captivates audiences but sparks debate over its practical utility in combat scenarios. On May 10, 2013, the F-35B completed its first ever vertical takeoff, VTO, and vertical landing, VL, at NAS Patuxent River, MD, during Flight Test 286. While VTOs are not intended for combat, they are crucial for repositioning the short takeoff and vertical landing STOVL jet in environments where short takeoff isn't possible. With limited fuel, The F-35B can perform a vertical takeoff for short distances, showcasing versatility in challenging conditions, essential for operational flexibility. The F-35B's versatility extends to its weaponry, such as the embedded gun, which enhances its combat role, but raises ethical questions about the proliferation of advanced armaments. The F-35A's embedded gun, located in the left wing root, fired a 181-round burst. This gun enhances the F-35A's capabilities, allowing pilots to engage air-to-ground and air-to-air targets with strafing, alongside advanced beyond-visual range air-to-air missiles and precision-guided air-to-ground weapons for versatile combat operations. Lockheed Martin's Electro-Optical Targeting System, EOTS for the F-35 Lightning II, enhances air-to-ground and air-to-air targeting. EOTS combines FLIR, forward-looking infrared, and IRST, infrared search and track technologies, providing high-resolution imagery, automatic tracking, and laser designation. Integrated into the fuselage behind a durable sapphire window, it supports air-to-air and air-to-surface missions. EOTS's production involves multiple Lockheed Martin facilities, ensuring high performance, cost efficiency, and rapid maintenance for mission readiness across all F-35 variants. The LHD Juan Carlos I L-61, built by Navantia, is a versatile platform for amphibious operations, force projection, humanitarian missions, and serving as an aircraft and helicopter carrier. Measuring 230.8 meters in length and 32 meters in beam, with a displacement of 27,560 tons, it reaches 20 knots fully loaded and has a 9,000 nautical mile range at 15 knots. The 5,440 square meters flight deck features a ski jump ramp and 2 aircraft elevators, supporting up to 20 AV-8B or F-35B aircraft. It includes a 985 square meters hangar, vehicle garages, and a well deck for 4 LCM-1E landing craft and 4 Supercat vessels. It accommodates 1,435 personnel, including crew, command staff, air wing, beach group, and embarked forces. Medical facilities include 2 operating rooms, an ICU for 8 patients, an isolation ward for 4, and 26 beds. Built to military and SOLAS standards with NBC Defense, it carries 145 containers, has desalination and power plants, and modular accommodation for up to 1,000 evacuees. 2 sister ships, HMAS Canberra and Adelaide, were delivered to Australia. The LHD's modular design echoes the construction of the Arm Reformador, a patrol vessel that showcases international cooperation, but raises questions about the globalization of defense manufacturing. At WBP Rogow, Poland's renowned small arms manufacturer, the legacy of the Kalashnikov rifle lives on, refined, re-engineered, and reintroduced with modern manufacturing precision. Currently in development is their AKM pattern rifle, designed to maintain the iconic platform's reliability while integrating enhancements that meet today's tactical standards. Each rifle begins as a forged front trunnion, machined in-house to exacting tolerances, matched with a cold hammer-forged 16.3-inch barrel, chambered in 7.62 x 39 millimeters. The system is optimized for both longevity and consistent accuracy. The stamped receiver, faithful to original Soviet specifications, is heat-treated for enhanced durability and long-term performance under stress. Attention to detail is a hallmark of WBP's process. Bolt carriers are precision ground, then test-fitted to ensure smooth cycling. Riveting, often overlooked in modern clone builds, is completed with jigs and hydraulic presses that match military-grade standards. The fire control group features a smooth, consistent trigger pull with reset tuned for predictable follow-up shots. Furniture options include traditional laminated wood, produced locally in Rogow, as well as polymer variants for users seeking weight reduction or accessory compatibility. A classic slant brake comes standard, but the threaded muzzle allows for various suppressor or compensator attachments. Every rifle is tested and inspected before shipping. Headspace, trigger function, gas port alignment, and sight zeroing are all verified. WBP's commitment to quality ensures these rifles not only preserve the AKM heritage, but deliver enhanced battlefield performance. As WBP Rogow finalizes this AKM variant, it positions itself as a leading European source for modern Kalashnikovs, trusted by civilian shooters, collectors, and military surplus enthusiasts alike. Combining time-tested design with 21st century engineering, WBP's AKM is a modern classic in the making. Digital transformation is revolutionizing aircraft production. From day one, programs like Future Vertical Lift have embraced digital tools to reduce cost and speed up development. At Sikorsky, innovations like the 3D Experience platform integrate design, manufacturing, and inspection data, enabling smarter decisions, faster timelines, and lower costs. A heated steel ingot is transformed into a gear blank through precision forging using a 5,000-ton hydraulic press. At elevated temperatures, the ingot becomes plastically deformable, allowing the immense force of the press to shape it into a near-net form. The controlled application of pressure ensures optimal grain flow, enhancing the mechanical properties of the final component. This process requires precise temperature control, die alignment, and press timing to achieve uniform density and dimensional accuracy. Forging under such tonnage increases fatigue, strength, and impact resistance, making the resulting gear blank ideal for demanding applications such as heavy machinery, automotive drivetrains, or industrial gearboxes. The GI-6V is an advanced sorting and gauging system designed specifically for high-speed inspection of 9mm to .50 caliber cartridges. Starting with a low-profile 5 cubic foot hopper and bucket elevator, cartridges are fed into a centrifugal bowl and oriented using vision-guided blow-off technology. 8 high-resolution cameras and multiple strobes capture the full 360-degree profile, detecting visual defects on the primer, bullet, and case circumference. A super eddy current sensor identifies missing lead cores, while laser gauging ensures precise dimensional control. Capable of sorting up to 300 rounds per minute, the GI-6V combines speed, accuracy, and adaptability for modern ammunition inspection lines. For nearly 40 years, BFW has specialized in high-precision, multifunctional turning and milling centers. These machines enable complete part machining in a single setup, replacing multiple conventional tools. Built on massive cast-iron beds, they offer exceptional rigidity, thermal stability, and vibration control. Integrated measurement systems and advanced CNC cycles allow automatic, operator-free inspections to maintain tight tolerances. With features like 5-axis machining, digital twin integration, and automatic tool changers, BFW machines are ideal for industries demanding complex, large-scale components. Their technology ensures reduced cycle times, superior part quality, and unmatched precision, engineered for efficiency, reliability, and long-term industrial performance. Milling with the swiveling B-axis on the M65 mill turn enables precise machining of flats and slots at any angle. With simultaneous interpolation of up to 5 axes, the system allows for complex geometries and contours, offering exceptional flexibility and precision in multi-axis machining operations. Prakash Yantra Udyog (PYU Forge) is a specialized manufacturer in the field of heavy open die forging and precision CNC machining. Its forging division features 2 high-capacity hydraulic presses, 5,000 tons and 1,500 tons, paired with 30-ton and 10-ton manipulators, enabling the precise handling and deformation of large workpieces. These machines produce high-integrity components with optimized grain flow and superior mechanical properties. The integrated heat treatment facility supports key processes such as normalizing, quenching, tempering, and slow cooling in sandpits. Electric and gas-fired furnaces, equipped with energy-saving recuperators, ensure uniform thermal treatment for improved microstructure and hardness control. Quality assurance is conducted through comprehensive non-destructive testing, including ultrasonic testing, UT, magnetic particle inspection, MPI, and dye penetrant testing, DP, ensuring defect-free forgings. The CNC Machining Center includes vertical turning lathes, VTLs, horizontal borers, high-capacity lathes, and 5-axis milling machines. PYU specializes in complex components like turbine shafts, gear rings, hollow tubes, and Pelton runners, machined to tight tolerances with CAM-assisted programming. Committed to sustainability, PYU integrates solar energy and zero-emission electric furnaces. With advanced technical infrastructure and stringent quality systems, PYU delivers critical components for nuclear, hydro, mining, and marine applications. The German Submarine U32 is a cutting-edge vessel of the Type 212A class, designed for stealth, endurance, and high underwater performance. Built by Nordseewerke in Emden, U32 is a conventional high-seas submarine that incorporates some of the most advanced non-nuclear technologies in the world. With a displacement of 1,450 tons on the surface and 1,830 tons submerged, U32 measures 56 meters in length, 7 meters in width, and 11.5 meters in height over the sail. It is capable of diving to operational depths of at least 400 meters, enabling it to perform deep water missions with ease and discretion. The propulsion system is a hybrid of diesel and air-independent technology. It includes a 1,050 kilowatts diesel engine, 9 hydrogen fuel cell modules producing a total of 306 kilowatts, and a powerful electric motor delivering 1,700 kilowatts, about 2,318 horsepower. This system allows the submarine to operate extremely quietly, ideal for covert operations. Armament includes 6 533mm torpedo tubes, capable of launching up to 12 German Marks IIA 4 Seehecht heavyweight torpedoes, which are fiber optic guided for high accuracy. U-32 can also deploy 24 underwater mines for strategic area denial. With a crew of 26, U-32 reaches speeds of 12 knots on the surface and 20 knots submerged. The submarine's design emphasizes reduced acoustic signature, extended underwater endurance, and exceptional operational flexibility, making it one of the most advanced non-nuclear submarines in service today. The integration of an articulated robot with the WFLM-35 GMILLTURN offers one of the most advanced and flexible automation solutions in modern machining. This combination allows for fully automated, continuous operation, ensuring uninterrupted productivity and consistently high-quality results. The M35 GMILLTURN itself is a multifunctional machine capable of operating as a high-precision lathe, a 5-axis machining center, and even performing specialized tasks such as gear cutting and deep-hole drilling. With a swing capacity of up to 520 millimeters and a machining length of up to 2,000 millimeters, it is ideal for complex shaft and chuck part production. When housed within an automated cell, the articulated robot contributes significantly to overall efficiency. It enables rapid cycle times by handling material loading, unloading, and even tool or clamping device changes without operator intervention. This minimizes downtime and allows for uninterrupted machining across multiple shifts. High repeatability ensures consistent part quality, while the automation minimizes human error. The robot's programmability allows it to adapt quickly to different production requirements, supporting fast changeovers and short-run flexibility. In terms of cost-effectiveness, the system reduces labor needs and lowers operating costs through optimized energy use and reduced tool wear. Additionally, the robot alleviates physically demanding or hazardous tasks from human workers, improving ergonomics and workplace safety. Its ability to operate in demanding environments adds another layer of protection to personnel. Furthermore, the system's modularity allows for scalable expansion. As production demand grows, additional robots or machining centers can be integrated seamlessly into the existing cell. This future-proof architecture ensures manufacturers can remain competitive in fast-evolving markets. The entire setup can also be integrated with MES, manufacturing execution systems, and digital monitoring platforms, enabling real-time data analysis, predictive maintenance, and smart factory applications. These capabilities not only improve equipment utilization, but also enhance traceability and quality control. Overall, the synergy between the M35 GMILLTURN and articulated robotics exemplifies the direction of modern industrial automation, prioritizing precision, flexibility, safety, and sustainable productivity. For industries requiring high-quality machining of complex components with maximum uptime, this configuration stands out as a powerful and forward-thinking investment. Passivation is a critical process that enhances the corrosion resistance of stainless steel by removing surface impurities and restoring the protective chromium oxide layer. Manufacturing steps such as cutting, welding, or machining can compromise this passive layer by embedding free iron and contaminants. Electropolishing, an advanced surface treatment method, not only smooths and deburrs components but also effectively removes these impurities, achieving superior passivation. Unlike nitric or citric acid passivation, electropolishing ensures a cleaner, more uniform passive surface. Certified methods, such as ASTM A967 and ASTM B912, validate the process through tests like copper sulfate and salt spray. Electropolishing not only boosts corrosion resistance, but also improves aesthetics, simplifies cleaning, and enhances product longevity. As such, it's widely adopted in industries requiring high-performance stainless steel components, including medical, aerospace, and food processing. New England Electropolishing offers expert services, including free sample processing and full certification. The NTX 2500 second generation demonstrates exceptional cutting capabilities across a range of operations on S45C carbon steel. With a cutting depth of 10 mm in OD cutting, its high rigidity structure ensures stable, heavy-duty performance. The Turnmaster spindle delivers outstanding durability and cutting power, while the Compact Master tool spindle enables precise face milling at 3.1 mm depth with excellent productivity. Tapping operations M33x P3.5 benefit from the high-torque tool spindle, expanding machining versatility. The optional Turret 2 enhances efficiency in secondary and back machining. Equipped with a BMT turret and ± 40 mm Y-axis travel, the NTX series guarantees accuracy and reduced cycle times. The Okuma LB3000 is a high-precision CNC lathe equipped with main and sub-spindles, a driven tool turret, and the advanced OSPP300LA control system. Designed for complex machining of CRMOV alloy steel, 19,573, it features X/Z axis travels of 260 mm and 995 mm respectively. The main spindle, JISA26, delivers 45 to 5,000 revolutions per minute with a bore of 80 mm, while the sub-spindle reaches 6,000 revolutions per minute. The 12-station turret handles 25 x 25 mm turning tools and E40 mm boring bars. Cutting operations include roughing, V-profile turning, VC equals 150 to 170 meters per minute, grooving, VC equals 60 to 90 meters per minute, and drilling with E30 mm tools to 90 mm depth. The anti-vibration boring bar and E10 mm end mill enable stable finishing, while high feed accuracy ensures tight tolerances. Tongue alloy cutting tools were used throughout the process, including inserts for grooving, external and internal turning, drilling, and face milling. This setup enables efficient, high-quality machining of tough alloy steels. The F-35 flight trials, regarded as the most sophisticated and rigorous in aviation history, have successfully concluded. The program included over 9,200 test flights and more than 65,000 test points, demonstrating the aircraft's advanced capabilities. Key achievements include F-35A and F-35B in-flight weapons testing, the first F-35 delivery to the U.S. Marine Corps, and the first international delivery to the U.K. The Eglin AFB operational utility evaluation was completed in just 47 days, ahead of the original 65-day schedule. Trials featured night flights, air refueling, high angle of attack tests, air starts, and fly-in hook arrestments for carrier compatibility, with 2,106 flights during the developmental test phase. The F-35's performance was validated through high angle of attack testing, demonstrating superior maneuverability and air refueling capabilities for extended mission endurance. The high-speed, high-performance system excelled in night operations, weapons deployment, and air combat scenarios. With over 100 aircraft delivered to operational units and partners, the F-35's trials position it as a cornerstone of naval and Air Force aviation, providing unmatched stealth, versatility, and readiness for combat across global theaters. The program affirmed the F-35's multi-domain integration, enhancing air superiority, strike missions, and intelligence, surveillance, and reconnaissance (ISR) in real-world environments. Compatibility across multiple environments ensures readiness for peacekeeping and combat operations, marking a leap in modern warfare. Successful trials paved the way for scaled-up production, but Lockheed Martin's delivery achievements raise questions about whether the F-35's economic benefits outweigh its reported $428 billion price tag. The F-35B, part of the fifth-generation fighter jet family, is revolutionizing naval aviation, particularly for the UK's Royal Navy. It is set to be the primary weapons system aboard aircraft carriers. Operating from amphibious assault ships like the USS Wasp, it demonstrates versatility and value to carrier aviation, addressing evolving threats. For the UK, transitioning from the Harrier, the F-35B offers advantages in safety, handling, and performance. Unlike the Harrier, which required constant control refinement, the F-35B simplifies operations, making it safer to fly in low or high wind conditions. Its design ensures a smoother, less stressful flying experience, crucial for carrier operations. The jet excels in catapult launches, night flying, and diverse weather, demonstrating exceptional control and stability. Recent trials showed its ability to take off with weapons on board, with minimal impact on handling, enabling a wide range of missions. Its maintenance ease accelerates repairs, ensuring mission readiness. Successful catapult tests and night operations prove the F-35B meets Navy needs, marking a milestone toward integrating fifth-generation technology into naval operations, redefining the future of naval aviation. The initial sea trials of the F-35C aboard the USS Nimitz marked a historic milestone for both the U.S. Navy and the fifth-generation fighter program. In just 2 weeks, extensive tests were conducted, including catapult launches, arrested landings, and operations in a variety of wind and deck pitch conditions. The jet's performance was lauded for its stability, control, and reliability, even during challenging night operations. Engineers and maintainers were impressed by how manageable the aircraft was on deck, with minimal malfunctions and quick turnarounds when issues did arise. One of the most significant breakthroughs was validating the Delta Flight Path System, which precisely controls glide slope on approach. These trials confirmed not only the aircraft's technical readiness, but also instilled confidence in pilots who reported that the F-35C trapped successfully even under reduced weather minimums. With this success, the program is now positioned to move into the next phase of testing: external stores, maximum weight catapults, and asymmetrical loads, paving the way for full operational integration aboard carrier fleets. As these sea trials demonstrated the F-35C's readiness for carrier-based missions, pilot training becomes even more critical. highlighting the role of high-fidelity simulators in preparing aviators for the demands of fifth-generation air combat.